Hi students, good morning. There is a new chapter. We want to start that. That is number system. In that part, I want to take that introduction part and the operation on real numbers. Yes. First, just I want to remind you what you learned in your 8th class. That is number system. Set of natural numbers, set of whole numbers, set of integers, set of rationals, set of irrationals, then set of real numbers. You know very well about that set of natural numbers and how we are going to operate on that. Yes. So just I want to remind you, natural number, the set of natural number is set of counting numbers. Set of counting numbers. How do we count that? That is 1, 2, 3, 4, 5, 6, 7. These are said to be counting numbers, so they are called natural numbers. That set is denoted by capital N. And W, which shows set of whole numbers. That whole numbers means we know that when 0 is also a number which included to the natural numbers, then the set is said to be set of whole numbers. I think you already know very well about that, just I am reminding that. So 0, 1, 2, 3, 4, 5, so on, they are said to be set of whole numbers. That is denoted by capital W. And set of integers. What are integers? So and also know about how we are going to represent the numbers on number line. At that time there are 0 is reference number. When we are counting that 0, 1, 2, 3, 0 onwards, rightwards. That's when we are going to number that. That's going to be positive integers. Before, in opposite of that positive numbers, -1, -2, -3, -4, like that, they are said to be integers. So set of integers is denoted by Z. Then what about rational numbers? What about rational numbers? Rational number is denoted by Q. Set of rational numbers is denoted by Q. Generally we are defining that E is in the form of P by Q, where P and Q are integers, and with one condition, Q should not be equal to 0. Q should not be equal to 0. Whatever the number you can tell, whatever number you can tell with the help of integers. They must be in the form of P by Q, simplified form, 2 by 3. 1 is also integer, also whole number, also natural number. Is it? So like that. So set of rationals is denoted by Q, which is in the form of P by Q, where P and Q are integers with condition Q should not be equal to 0, means the division part must not be 0. It means you can understand 2 by 0 what it means? Meaningless, not possible. But 0 by 2? Okay. So like that, Q should not be equal to 0. Then what about irrationals? What about irrationals? So generally we are defining which are not possible to put in the form of P by Q. Which are not in the form of P by Q. At that time what is irrationals. So just I want to remind that. Just for example, 1 by 3 is a rational number. So what is the value of this? This is 0.333333. That is means a recurring decimals. That is a recurring decimals. See? So what are that? One example, 6 upon 3, it means 2. Yes, 10 by 2 equal to 5. And so many examples can be that. And 3 by 6, it means 1 upon 2, it means 0.5 stops here. Yes. Here the decimals are said to be terminating decimals in this case. In this case, decimals are said to be recurring decimals. Terminating decimals and recurring decimals are also called rational numbers. Yes, where there is not possible to put terminating decimals, recurring decimals. At that time, according to this, they are said to be irrational numbers. Just for example, root 2. We know very well about that. Square root of 4 is 2, but square root of 9 is 3. But what is the value of square root of 2? There is a method, it is said to be division method, that by the help of that division method, we can get the value of 1.4142. Then what the number comes we don't know. It means such numbers which are non-recurring, which are non-terminating. So non-terminating, non-recurring decimals are said to be set of irrational numbers. Irrational. Again like that also. Root of 3, square root of 3, that is 1.73 like that, which will not stop, but also not recurs. Yes, some groups, sometimes one number or two numbers, three numbers will not repeat at all. So such numbers means non-terminating, non-recurring decimals are said to be irrationals. That is said to be Q dash. It means you can tell root 2, root 3, root 5 and so on. These are said to be irrational numbers. So that what they tell, which cannot be put in the form of p by 2, that p and q are integers. So once again that what I want to remind that non-recurring, non-terminating decimals are said to be set of irrationals denoted by q dash. So now q union set of rationals union q dash, which is said to be set of real numbers denoted by r. Q set of rationals which contains integers. Integer contains whole numbers. Whole numbers contains natural numbers. Other than these, which are non-recurring, non-terminating decimals are said to be irrationals. So Q union Q dash gives the set of real numbers that is denoted by R. So now root 2 is said to be irrational. So what is root? Root is said to be radical sign. Radical sign, or sometimes I call it is general form is said to be nth root of a. It means what? What are we calling here? Square root. It means 2. Square root of 2 is square root of 3. Or cube root of 4. Yes, 4th root of 6. Whatever it is. So 10th root of 2. That is here. Such numbers are called irrational numbers. So here general form is nth root of a. Is also called radicals or candle surd. General form of surd is nth root of a. What is n? N is called order. A is called radicand. A is called radicand. So for example, what is the order? 3. What is the radicand? 4. Order 4. Radicand 6. Order 10. Radicand 2. Yes, such numbers are said to be irrational numbers. Today you want to know about how we are going to operate the real numbers, particularly related to irrational numbers. Okay. And we know very well about that closure property. commutative property, closure law, commutative law, associative law, distributive law or distributive property. Yes, these are all studied commutative property about real numbers. Okay, so the real numbers contains rationals and irrationals. Rationals means integers, integers means whole numbers means natural. Okay, so now and just for example, is 2 plus root 3 is rational or irrational? Question is 2 plus root 3. 2 is a rational number, 3 is a irrational number. Just for example, 2 plus 1.73, it means 3.173 again. It will gives irrational number, which we can tell non-terminating, non-negative. So 2 plus root 3 is irrational number. It means sum of rational number and irrational number is irrational number. Like that also 2 minus of root 3, difference of rational number and irrational number is again irrational number. And 2 plus root 3 into root 2. Yes, understanding? 2 multiplication. 2 into root 2 is 2 root 2 plus root 3 into root 2 is root 6. Again it is rational number. So irrational number. Product of irrational number and irrational number is rational number. Sometimes you can get rational numbers like that. Yes, 2 plus root 3 into 2 minus root 3. What is this? This is irrational number. This is also irrational number. So product 2. This is a plus b, a minus b, a square minus b square equal to 4 minus 2 and 2 can cancel 3, which is rational. Sometimes product may be rational or irrational. Like that division. Just for example, 1 by root 2. 1 is rational number, root 2 is irrational number. Again we are getting irrational number. Division of rational and irrational is irrational. So these are some properties. Okay. So they are given in the form of laws. Some laws, that is root of a into b equal to root a into root b. Root of a by b equal to root a divided by root b. Root a plus root b into root a minus root b equal to a minus b. A plus root b into a minus root b equal to a square minus b. Root a plus root b into root a equal to root AC plus root AD plus root BC plus root BD. Simple example there, just again some clarification I want to do here, that is nth root of A is called surd or radical. So n is said to be order and A is said to be radical. A is non-perfect square number. N is positive integer, that is n is order. Yes, so this is called surd. With the help of this you can tell here root A into root B means here 2. Square root of means order is 2. When order is same at that time you can tell nth root of A into B into nth root of A into nth root of B. N whatever may be, it may be 2, it may be 3, cube root, 4th root, 10th root. If two radicals having same order with different radicals, keeping the order same, multiply the radicals. Just for example, root 3 into root 5. Order is 2. So keeping that root, that is 3 into 5 equal to root 15. That is clear. Here order not mentioned, only square root order is given. So like that nth root can give that. And that is actually the surd form, order and radical. Okay. And similarly, that is nth root of A by B is equal to nth root of A divided by nth root of B. Actually, this is the meaning, but in the textbook they are not given, only square root only given. So now, nth root of A plus nth root of B into nth root of A minus nth root of B. At that time, when it is same, at that time the value is equal to A minus B in this way. When n is same, the value is. So like that. Yes. This is just laws are given. So according to laws we are going to solve the examples. Very simple examples are given. Okay, so many points are being studied. Yes. So just you can consider that I want to find you root 2 is called monomial. S 2 plus root 3 is called binomial. S and 2 plus root 3 bracket square of binomial, square of binomial. S now product of two binomials, product of two binomials. So that is 3 into bracket 2 plus root 2 plus root 3 into bracket 2 plus root 2. Can you name them? The root law is applied here. Yes, here the law is applied. Distributive law. What is the distributive law? A into bracket B plus C is equal to AB plus AC. This distributive property is used. So according to that, now multiplication. 3 into 6 plus 3 into root 2 is 3 root 2 plus root 3 into 2 is 2 root 3 plus root 3 into root 2 is order same, multiply the and 3 to the 6. This is the last answer. Product of two irrational numbers is again irrational number here according to the law. What is the number here? Okay. So simplify that. 3 plus root 3 into 3 minus root 3. Yes, a plus b, a minus b, a plus b into a minus b equal to a square minus b square. That law is applied. Yes, 3 square minus root 3 bracket square. 3 square is 9. Root 3 bracket square is root and square get cancelled minus 3 equal to that is 6. That is your answer. In this way, I am going to apply the rule. Yes. Root 5 plus root 2 bracket square. Root 5 plus root 2 bracket square. Here a plus b bracket square is used. A plus b bracket square equal to or capital root a plus root b bracket square. Yes, square of binomial plus root a bracket square plus 2 into root a into root b plus root b bracket square equal to root and square cancel a plus 2 root of a into b plus b. That is simplification. So here root 5 bracket square plus 2 root of 5 into root 2 plus root 2 bracket square. According to law. Very simple example that given in the textbook. Equal to 5 plus 2 root of 5 to the 10 plus square root of 2 square means 2 equal to 7 plus 2 root 10. That is the answer. This is simplification what they are giving. Yes, this is a simple example. So next point is Rationalization. What is meant by rationalization? So just for example, root 2 is a irrational number. Root 2 is a irrational number. So how you are put that irrational number to rational number? Whatever operations you can do, addition, subtraction, multiplication, division. Yes, this is irrational number. We want to convert that into a rational number. Just to see that root 2 when it is multiplied itself equal to root 2 into root 2 is root 4, which is equal to 2, which is rational. Understand that? Yes. So now root 5 is multiplied root 5 equal to 5 is rational. So one question arises now. 2 root 3 is irrational number. 2 root 3 is irrational number. So what we are going to multiply to convert that irrational number to rational number? Is it 2 root 3 or root 3 only? Which is necessary, that is only applied. 2 root 3, okay. Some of them will answer 2 root 3, yes, 2 root 3. But other than that, again one answer. Yes, so that is 2 root 3, just it is multiplied by root 3, which is equal to 2 into root 3 into root 3 is root 9, which is equal to 2 into 3, which is equal to 6, which is rational. Understanding? Is it? So here only, here 2 is said to be multiplied. It is said to be surd. Only surd is applied to multiply. It becomes a rational number. Again one question now. 3 plus root 2 is binomial surd. So what are we going to multiply to convert into the rational number? So that is, we know that root a or a plus root b. A plus root b into a plus root b, so a minus root b is equal to a square minus b. That means 3 plus root 2 when it is multiplied by 3 minus root 2, at that time a plus b into a minus b equal to a square minus b square equal to 9 minus root 2 and square cancel 2 equal to 7, which is rational. Understanding? Is it? So it means to convert the given irrational number to rational number, irrational number to rational number, irrational number to rational number, irrational number to rational number is said to be, this process of converting the irrational to rational is said to be a rationalization. Is it? Understood that? So it is to convert the given irrational number to rational number. This process is said to be a rationalization. At that time the condition is to remember, here root 2 is given, this root 2 is multiplied. Root 5 is given, root 5 is multiplied. 2 root 3 is given, root 3 is multiplied. 3 plus root 3 is given, this is multiplied. Yes, are said to be a rationalizing factor. A rationalizing factor means root 2 is said to be a rationalizing factor of root 2. Root 5 is said to be a rationalizing factor of root 5. Root 3 is said to be a rationalizing factor of 2 root 3. 3 minus root 2 is said to be a rationalizing factor of 3 plus root 2. 3 plus root 2 is said to be a rationalizing factor of 3 minus root 2. Rationalizing factor each other. So by that of rationalizing factor, just to multiply and try to convert the rational numbers. So what is it is concluded? The process of converting irrational number to rational number is said to be rationalization. Okay. So generally we can take that. rational factor in root of a only. Yes, a root b. Don't think like that. Yes, b root a is equal to root a only. Yes, a plus root b. Rational factor is a minus root b. Root a plus root b. Root a minus root b. These are said to be rational factors. So x root a plus x root b, whatever you can take, x root a minus x root b. That's what we got. So understand, only thing is applying the a plus root a plus root 2 or a plus root a minus b, a square minus b square. Here also a plus b, a minus b. That you multiply, you are getting the rational factor, and then you have to simplify to put in the rational number. So one example. Rationalize the denominator. Rationalize the denominator of given example is 1 by root 2. The question is rationalizing the denominator. You should not think about numerator, only denominator. Here root 2 is there. What is the rational factor of root 2? Root 2 itself. So that is to multiply and divide. So which is equal to 1 by root 2 into root 2 by root 2. There is no change at all. Our work is to rationalize the denominator. So multiply and divide with the number which is the rational factor of the denominator. Is it? So equal to numerator is 1 into root 2 is root 2. Root 2 into root 2 is root 4, which is equal to 2. So denominator is rational number. So this is your answer. Okay. This rationalizing the denominator 1 upon root 7 minus root 6. Yes. What is the rational factor? Yes. Rational factor of root 7 minus root 6 is this you can take or this you can take. Root 6, root 7 minus root 6, root a minus root b. Rational factor is root a plus root b. That is multiply and divide. Root 7 plus root 6. Multiply and divide. 1 upon root 7 minus root 6 into root 7 plus root 6 divided by root 7 plus root 6. Means no change at all. So that is very important. Equal to numerator is as it is root 7 plus root 6 divided by a minus b, a plus b, that is a square means 7, b square means 6, equal to root 7 plus root 6 divided by 1. Denominator is rational number. Denominator is rational number. Rationalizing the denominator. Here, rationalizing factor of root 7 minus root 7 minus 2 is root 7 plus 2. That will multiply and divide. 1 upon root 7 minus 2 into that is root 7 plus 2 divided by root 7 plus 2. which is equal to simplify. 1 is the root 7 plus 2. 2 is put outside. 2 is here rational number. This is rational number. Yes. Root 7 bracket square is 7 minus 2 square is 4 equal to root 7 plus 2 divided by 3. That 3 is a denominator as a rational number. So in this way we can rationalize the given irrational numbers. Okay. This seminar is something for simple. 2 plus 2 bracket square 2 plus root 2 into 2 minus root 2 plus root 3 bracket square. Rationalize the denominator. Rationalize the denominator. One form 5 plus root 2 root 7 minus root 5 divided by root 7 plus root 5. 7 plus 3 root 5 divided by 7 minus 3 root 5. 2 root 3 minus root 5 divided by 2 root 2 plus 3 root 3. So very careful try to understand. You can easily simplify this, but rationalization here numerator is 1 only, but here numerator is different. So when you are multiplying rational factor, at that time also numerator have to multiply and put the answer. Only the case is, only the thing is, your denominator must be rational. So here try to solve the examples. Yes, we will see you tomorrow next class about laws of indices. Okay, thank you.